Let me destroy a fantasy right now. You know those videos showing people plucking glittering gemstones from crystal clear streams? That's not how it works. Real gem prospecting means learning to recognize ugly rocks that indicate beautiful stones nearby. The romantic notion of stumbling across a sparkling sapphire sitting on top of the ground? Forget it. Weathering, oxidation, and surface coatings make even the finest gems look like muddy pebbles in their natural state. That's precisely why indicator minerals are so powerful. They don't lie. They're formed by the exact same geological processes as the valuable gems you're seeking. Professional miners don't wander around hoping to spot sparkle. They systematically search for indicator minerals, then excavate the surrounding material, knowing that's where concentrations of valuable stones actually occur. I'm not going to promise you'll find a $10,000 sapphire on your first outing. What I will promise is this: once you understand these 5 indicator minerals, you'll never look at a riverbed or hillside the same way again. You'll develop what experienced prospectors call educated eyes, the ability to spot geological significance in rocks that others dismiss as worthless gravel. Indicator number 1, Chromite, diamond and ruby indicator. First, you have to understand Chromite, and this is the mineral that changed everything for me. Chromite looks like small black metallic fragments with a brownish-red streak. When you see it, you're not looking at something pretty. You're looking at dark, heavy particles that have an almost greasy metallic shine. Here's the exact identification process. Pick up a suspected chromite grain. It should feel significantly heavier than a similar-sized piece of quartz or regular rock. We're talking about specific gravity of 4.5 to 5.5, which means it's nearly twice as heavy as ordinary stones. The metallic luster is the telltale sign. It looks like tarnished metal, not like glass or regular minerals. Now do the streak test. Rub it across unglazed porcelain or a ceramic tile. Chromite leaves a brown or brownish-red streak, never black, despite the mineral itself appearing black. If you see a black streak, you're looking at magnetite, which is common and worthless as an indicator. The reason chromite matters? It forms in ultramafic rocks, the same geological environment where diamonds and certain rubies occur. Professional diamond prospectors in places like Arkansas specifically search for chromite concentrations because they indicate kimberlite pipes or placer deposits that could contain diamonds. The shape you're hunting for: irregular metallic grains ranging from sand-sized particles to pea-sized chunks. In stream beds, they accumulate in the same areas as gold, inside bends, behind large boulders, in bedrock crevices, because both are heavy minerals that settle out. First, indicator number 2, Ilmenite, sapphire indicator. Second, you need to recognize Ilmenite. This is the number 1 sapphire indicator mineral, and it's everywhere sapphires occur. Ilmenite appears as black, metallic, plate-like, or tabular crystals with a black streak. Unlike chromite's brownish streak, ilmenite streaks true black. The metallic luster is more subdued than chromite. Think dull metal rather than shiny metal. The crystals often form distinctive flat tabular shapes that look like tiny metallic tiles or plates. When you're panning or screening material, ilmenite stands out because of its shape and its tendency to lie flat, due to its platy crystal structure. Weight is your confirmation. Ilmenite has a specific gravity of 4.5 to 5.0, making it substantially heavier than the quartz and feldspar that make up most stream gravels. If you're holding what looks like a thin, flat metallic chip that feels surprisingly heavy, you're likely holding ilmenite. Here's what most people don't know. Wherever you find concentrated ilmenite, you should be finding sapphires in the exact same deposit. They're both heavy minerals that formed in similar geological conditions and accumulated together during placer formation. Montana's famous Yogo Gulch, loaded with ilmenite. The sapphire deposits of North Carolina? Ilmenite everywhere. The critical visual difference between ilmenite and similar minerals: ilmenite is weakly magnetic, so a strong magnet will pull it, but not strongly. Regular magnetite jumps to magnets. Ilmenite hesitates, moves slowly, or only attracts when the magnet touches it directly. Indicator number 3, Pyrope garnet. diamond indicator. Third on your list is Pyrope garnet, specifically the deep red to purple variety that indicates diamond-bearing formations. Now, pyrope garnets themselves can be valuable, but their real importance is as the single most reliable diamond indicator mineral in existence. Visual identification starts with color. You're looking for garnets that are deep red, purplish red, or even black red. They're transparent to translucent when clean, with a vitreous, glassy luster that makes them stand out from ordinary pebbles. The crystal form is typically rounded or showing 12-sided dodecahedral shapes, though streamwear often creates smooth, rounded pebbles. The hardness is your field test. Pyrope garnet registers 7 to 7.5 on the Mohs scale, meaning it'll scratch glass easily and resist scratching from a steel file. If you can scratch it with a steel knife, it's not garnet. It's probably some variety of quartz or common rock. Here's the technique that separates beginners from experts, the heft test. Pick up a garnet and a similar-sized quartz pebble. The garnet should feel noticeably heavier, specific gravity of 3.7 to 3.9 versus quartz at 2.65. That difference is immediately perceptible once you've handled a few confirmed examples. Why pyrope garnets indicate diamonds? They form in the Earth's mantle under the exact pressure and temperature conditions required for diamond formation. When kimberlite pipes bring material up from deep in the mantle, they bring both pyrope garnets and diamonds. Finding concentrated pyrope garnets means you're in or near a kimberlite system. The color range matters for indication purposes. Chrome pyrope garnets, those with a distinctive purple-red color caused by chromium, are especially significant. These are the ones professional diamond explorers get excited about because they form at even greater depths where diamond stability is highest. Indicator number 4, Picroilmenite, diamond indicator. Fourth is Picroilmenite, which sounds complicated but becomes simple once you understand what you're seeing. This is ilmenite's magnesium-rich cousin that forms exclusively in kimberlite pipes, the volcanic formations that bring diamonds to Earth's surface. Visually, Picroilmenite looks nearly identical to regular ilmenite, black metallic, often forming hexagonal or tabular crystals. The black streak test will confirm it's in the ilmenite family. So how do you tell them apart in the field? You can't, reliably. That's the honest answer. But here's why it doesn't matter. If you're finding abundant black metallic minerals with flat hexagonal or tabular crystal shapes in an area where diamonds have been reported, assume you've found Picroilmenite and start excavating systematically. The weight test applies here too. Specific gravity of 4.0 to 4.5 means these crystals sink fast and accumulate with other heavy minerals. In placer deposits, Picroilmenite concentrates in the same pay zones as diamonds, gold, and other dense minerals. Professional diamond explorers use Picroilmenite as a vector indicator. They map where Picroilmenite concentrations occur, then trace them back to their source bedrock. Wherever Picroilmenite is weathering out of the ground, there's a kimberlite pipe somewhere upstream or uphill. The crystal form gives you clues about source proximity. Angular, fresh-looking crystals with sharp edges mean the source is close. Rounded, worn crystals indicate significant transport distance from the original kimberlite location strategy. Before you find your first indicator mineral, you need to understand where these stones form and how they move. All 5 indicators we're discussing are heavy minerals, substantially denser than the quartz, feldspar, and limestone that make up most surface rocks. This weight difference creates predictable concentration zones. When water moves sediment, heavy minerals settle out first. When you're prospecting streams, creeks, or rivers, you're not looking randomly. You're targeting specific microenvironments where heavy minerals naturally accumulate. Primary deposit locations. First, identify areas where the source rock is exposed or near the surface. For chromite, you're looking for areas with serpentinite, a greenish, often greasy-looking rock that forms from altered ultramafic rocks. These areas often appear as greenish or rust-colored exposures on hillsides. For ilmenite and sapphires, search for basalt flows or areas where volcanic rocks intersect with metamorphic formations. The Missouri River deposits in Montana, for instance, occur where ancient volcanic rocks weathered and released sapphires and ilmenite into the drainage system. For diamond indicators, Pyrope garnet and Picroilmenite, you need to research areas where kimberlite pipes have been documented. The honest reality? There aren't many publicly accessible diamond-bearing areas in North America. Arkansas's Crater of Diamonds State Park is the main public location, but understanding indicators helps you identify potential areas that haven't been thoroughly explored. Secondary placer locations. Here's where it gets practical for most prospectors. Secondary placer deposits form when weathering and erosion move indicator minerals and gemstones away from their source. These deposits are far more common and accessible than primary sources. Target inside bends of streams where water velocity decreases and heavy minerals drop out. Look for areas immediately downstream from bedrock riffles or waterfalls where turbulence creates separation zones. Search gravel bars, especially on the downstream side where fine material accumulates. Pay special attention to bedrock crevices, potholes, and irregular surfaces where heavy minerals get trapped during floods. These natural riffles work exactly like the riffles in a sluice box. They capture dense materials while lighter sediment washes away. Ancient stream terraces above current water level are premium locations. These represent old stream beds where heavy minerals accumulated over centuries before the stream cut deeper. Terraces often show as flat areas on hillsides above the active creek indicator mineral zones. Professional prospectors talk about indicator trains, the pathway of indicator minerals leading back to a source. When you find even a single pyrope garnet or chromite grain, mark that spot. Then systematically search upstream and uphill, mapping where concentrations increase. The highest concentration point in a stream typically occurs just downstream from where the source rock intersects the drainage. That's where you'll find the best potential for gemstone recovery. For hillside prospecting, look for erosion gullies, animal dig areas, and road cuts where fresh material is exposed. Indicator minerals weather out of host rock and move downslope through gravity and rain action. The base of steep slopes often contains concentrated material, essential equipment, budget under $50. All you need to get started: a gold pan or classifier screen, a small magnet, unglazed porcelain tile for streak testing, a steel file or knife blade, a 10x hand lens, and small containers for samples. Every item is available at hardware stores or online for minimal cost. The gold pan technique works identically for heavy indicator minerals. Fill your pan 2/3 with material from your target location, submerge it in water, and agitate to settle heavy minerals to the bottom. Gradually wash away lighter material using circular swirling motions. The systematic search process. First, you have to sample multiple locations within your target area. Don't just pan one spot and quit. Professional prospectors test every microenvironment: inside bends, behind boulders, bedrock crevices, gravel bars, and eddy zones. Take 20 to 30 pans from each promising area. Concentrate the material down to the final heavy black sands. This is where your indicator minerals will appear if they're present. Spread these black sands in a shallow layer of water in your pan. Now examine them systematically. The metallic minerals stand out immediately, black, shiny, and distinctive against the typically brownish or gray background of regular black sand, the identification sequence. Pick up suspected indicator grains with tweezers or your fingertip. First test: weight and heft. Does it feel substantially heavier than expected? That's your initial confirmation. Second test: magnetic response. Touch your magnet to the grain. Strong, immediate attraction means magnetite, common but not particularly useful as an indicator. Weak attraction or no attraction means you've potentially found chromite, ilmenite, picroilmenite, or pyrope garnet. Third test: streak. Rub the mineral across your porcelain tile. Brown or brownish-red streak indicates chromite. Black streak indicates ilmenite or picroilmenite. No streak or white streak with the mineral potentially scratching the tile indicates pyrope garnet. Fourth test for garnet specifically: hardness. Try to scratch the crystal with a steel file or knife blade. If the metal slides off without marking the stone, you've confirmed hardness above 6.5, consistent with garnet. Sample collection strategy. Once you've identified indicator minerals, it's time to expand your operation. Mark your location precisely using GPS coordinates or multiple visual landmarks. Then work in a grid pattern, taking samples every few feet to map the concentration. The highest concentration of indicators points to the source direction. Systematically move upstream or uphill, continuing to sample and map. Professional diamond explorers use this exact technique. Processing technique for volume. After you've identified a promising location with strong indicator minerals, you need to process larger volumes of material. Here's the budget-friendly approach. Use 5-gallon buckets and a classifier screen to separate material by size. Screen your material through 1/4 inch mesh first. The oversize goes into one pile for visual inspection. Larger garnets and gems will be caught here. The undersize goes into your pan for concentration. Process the concentrated material in batches. What you're creating is concentrated heavy material that's been processed to remove 95% of worthless lighter rocks. Your indicator minerals and any associated gemstones will be in these concentrates. Safety and legal considerations. Critical points: always verify you're on public land or have permission for private land. Many prime gem areas are on claims or private property. Respect all posted signs and seasonal closures. For stream work, be aware of flash flood danger, wear appropriate footwear for wet conditions, and never work alone in remote areas. Bring water, sun protection, and first aid supplies for full-day prospecting trips. When you find what might be valuable gemstones, resist the urge to do aggressive testing in the field. Scratching, hammering, or chemical testing can damage valuable finds. Collect samples and test them properly at home. Home testing methods revealed. Now here's where it gets interesting. Those confirmation techniques I promised at the beginning. You've collected your samples, identified your indicator minerals, and possibly found what might be gemstones. Time to validate everything using methods that cost practically nothing. The comprehensive hardness test. First, let's talk about proper hardness testing using household items. For less than $5, you can create a field hardness kit that definitively identifies most indicators and associated gems. Start with known standards. A copper penny represents hardness 3.5. A steel knife blade or file represents 5.5 to 6.5. Window glass represents 5.5. Your fingernail is 2.5. A ceramic tile is about 7. These everyday items bracket most minerals you'll encounter. The technique that changed everything for me, the progressive scratch test. Take your unknown mineral and start with the softest material. Can your fingernail scratch it? No? Move to copper. Does copper scratch it? No. Move to steel. Here's the critical detail. When testing, you're not gouging or grinding. You're making one firm, controlled stroke under moderate pressure. If you see a scratch line, the mineral is softer than your testing tool. If you see powder or marking from your testing tool but no scratch in the mineral is harder. Pyrope garnets will scratch glass easily but resist marking from steel. Sapphires and rubies scratch everything except diamond. Industrial quartz scratches glass but gets marked by a steel file with effort, the specific gravity water test. Second, you can measure specific gravity at home using just water, a scale, and basic math. This definitively separates light minerals from heavy indicator minerals. Here's exactly how to do it. First, weigh your dry sample. We'll call this weight A. Second, suspend the sample on a thread and submerge it completely in a container of water sitting on your scale. Note the weight increase. This is weight B. Calculate specific gravity using the formula A divided by B. Quartz gives you values around 2.65. Chromite gives you 4.5 to 5.5. Ilmenite shows 4.5 to 5.0. Pyrope garnet measures 3.7 to 3.9. These numbers don't lie. They're based on the atomic structure and composition of each mineral. For tiny grains too small to weigh individually, use the float sink method. Mix heavy liquids or dense solutions. You can make these with sugar or salt water. Then observe which minerals sink versus float. Heavy indicators sink in solutions that float quartz and feldspar. The thermal conductivity test for diamonds. Third, if you're in Arkansas or anywhere diamonds are possible and you've found a transparent crystal associated with pyrope garnet and Picroilmenite, here's the diamond confirmation technique using household items. Diamonds have exceptional thermal conductivity. They conduct heat away from your body faster than any gemstone imitation. The breath test works because of this property. Breathe moisture onto the stone's surface. On a real diamond, the fog evaporates almost instantly. On quartz, glass, or cubic zirconia imitations, the fog lingers for several seconds. For a more definitive home test, place the stone on a folded newspaper or magazine page with fine print. Look through the stone straight down at the text. If you can read any letters or see any clear text through the stone, it's not a diamond. Diamonds have such high refractive index that text becomes completely distorted and unreadable. The line test: draw a line with a pen on white paper. Place the stone table down on the line. With a real diamond, the line will split, distort, or become invisible due to the diamond's optical properties. With quartz or glass, you'll see the line continue clearly through the stone. Multi-mineral confirmation system. Fourth, use the association system as validation. Real gem deposits don't contain single isolated minerals. They contain characteristic suites. If you're finding what you believe are sapphire indicators, you should be finding ilmenite, zircon, and rutile together. The absence of these associated minerals should make you question your identification. For diamond indicators, pyrope garnet should appear with picroilmenite and chromite. Finding abundant chrome diopside, a bright green pyroxene mineral, further confirms kimberlite association. Create a reference collection of confirmed samples. Once you've positively identified chromite from one location, keep that sample as your standard. When you find suspected chromite at new locations, you can directly compare streak, luster, weight, and magnetic response. Success indicators and quality markers. That's how you'll know you found something real versus maybe. Multiple confirmation methods, all pointing to the same conclusion. That's scientific validation. For indicator minerals specifically, success means correct streak color matching the specific mineral, weight that feels noticeably heavier than quartz, appropriate magnetic response, or lack thereof, correct crystal form or grain shape, presence in logical geological context, and association with other expected minerals. For gem-quality stones, success indicators include hardness above 7 on the Mohs scale, transparency or translucency in good light, appropriate color and saturation, crystal form consistent with the gem type, size sufficient for practical cutting, typically above 5 millimeters, and location consistent with known deposits. The quality hierarchy. Understanding quality separation between industrial and gem-grade material saves time and focuses effort. Not every sapphire or garnet has significant value. Industrial-grade corundum, sapphire ruby family, shows heavy inclusions, poor color, opacity, or fractured surfaces. Gem-grade shows transparency, good color saturation, minimal inclusions, and intact crystal structure. For garnets, gem-quality pyrope shows deep red color, transparency, and sizes above 8 millimeters. Industrial pyrope is opaque, heavily included, brownish red, or fragmentary. Both indicate diamonds equally well, but obviously gem quality has additional value. Wait until you see what happens next when you learn about value multipliers. A single high-quality sapphire can be worth more than 100 industrial-grade stones. Transparency and color saturation create exponential value increases. Professional cutters pay premium prices for clean, transparent, well-colored material over 10 carats. Below that threshold, value drops substantially because cutting waste reduces the final stone size. Understanding these economics helps you focus on recovery methods that preserve larger crystals rather than fracturing everything. Realistic encouragement. Here's the part that most people don't want to hear but needs to be said. Finding significant gemstone deposits is difficult. It requires persistence, systematic methodology, and often many trips before meaningful results appear. But, and this is the critical but, the methodology works. Indicator minerals don't lie. They're direct evidence of gem-forming geological conditions. Every diamond mine, every sapphire deposit, and every ruby source was discovered by someone who understood these principles. You now have knowledge that most casual prospectors lack. That's your advantage. While others are randomly poking around hoping to get lucky, you're working systematically with geological science guiding your efforts. Starting your journey. Your first step is simple. Visit a legally accessible prospecting location in your area. Many states have public gem collecting areas specifically designated for recreational prospecting research. Your state's Geological Survey website for locations. Start with a single-day trip. Bring your basic equipment and specifically search for indicator minerals rather than expecting to find finished gems. Your goal is to practice recognition, develop your identification skills, and build confidence in the techniques. Join local gem and mineral clubs. These organizations regularly organize field trips to productive areas, provide identification assistance, and connect you with experienced prospectors willing to mentor beginners. The knowledge transfer from experienced collectors to beginners is invaluable. Your action steps. Before your next prospecting trip, research legal collecting locations in your region. Verify access rules and collect permits if required. Respect all private property boundaries and mining claims. Assemble your basic equipment kit. Everything we discuss costs under $50 total. You don't need expensive specialized equipment to get started successfully. Study reference photos of indicator minerals and gems. Build visual familiarity before you enter the field, so recognition comes naturally rather than requiring constant reference checking. Connect with your local gem and mineral club. These organizations exist in virtually every state and provide access to experienced collectors, field trip opportunities, and identification assistance. Start your own reference collection of confirmed specimens. Proper identification of one sample creates a standard for comparison with future finds. The rocks you've been walking past your entire life might be pointing to significant gemstone potential. Those ugly, worthless-looking minerals are actually nature's treasure maps, waiting for someone with educated eyes to recognize their significance. You now have that knowledge. You understand Chromite, Ilmenite, Picroilmenite, Pyrope, garnet, and their associations with valuable gems. You know where to look, what to look for, and how to confirm your findings. Unlike what most people think, gem prospecting isn't about luck. It's about knowledge, persistence, and systematic methodology. Every professional started exactly where you are now, learning to recognize indicators before moving on to successful gem recovery. Your journey starts with that first field trip. Get out there, practice these techniques, and start building your skills. The possibility is real. The gemstones are there. And now you have the knowledge to find them. If this video helped you understand indicator minerals and geological associations, hit that subscribe button and ring the notification bell. Share this with anyone interested in gem hunting because this knowledge becomes more valuable the more people understand the science behind successful prospecting. Drop a comment below telling me which indicator mineral you're most excited to search for and what region you'll be prospecting. I read every comment and often provide location-specific advice based on local geology. Now get out there and start finding indicators. Your first significant gem discovery is waiting. You just need to recognize the signs that lead you there. The investment perspective. Let's talk honestly about the economics of gem prospecting as a hobby versus as an income source. For most people, this is a hobby that occasionally produces valuable finds. The real return on investment is outdoor recreation, learning, and the thrill of discovery. Can you make money? Absolutely. But it requires either finding an exceptional stone, discovering a productive location you can work repeatedly, or developing expertise that lets you recognize value. Others miss the most successful gem prospectors treated as a long-term accumulation strategy. They consistently collect quality material over months and years, eventually having enough gem-grade stones to sell as a lot or to have cut into finished gems. Indicator minerals play a crucial role in this strategy because they let you focus effort on productive areas rather than wasting time in barren locations. Time efficiency directly translates to better economic returns.